Let's take a look at problem 3.223. We're looking at the empirical rule. You have this data. You would open it up in StatCrunch. And once you open in StatCrunch, you want to take a look at its distribution. And then to look at its distribution, that means you want to look at a histogram. And so we look at the histogram of this data, and we see it's approximately normal, which then means, or bell-shaped, which means then we can apply the empirical rule. You need to summary stats this so that you can find the standard deviation and the mean. And then once you have those values that we have here, 0.839 and standard deviation 0.063, we can then go ahead and apply the empirical rule to this and answer the questions here. So you would do that, and then you have this data here. We know that and so what's going to happen here is to answer the questions about what percent, what happens is we draw a normal or a bell-shaped normal curve to approximate all of that data. We know that the mean of this, and we know what the standard deviation is, 0.063, and then we knew that the mean was for this from our work here, we know the mean was 0.839, looking at this here, 0.839. And so then answering these questions, what percent of the data is between 0.0713 and 0.0965? We know this is 0.839, and then what we end up doing is marking these off by standard deviations. And so then we know that this is one standard deviation away, so you do 0.839 plus 0.063, and so then you know you got that there. 0.902 would be this mark here. And then with that, two standard deviations is you're going to go ahead and add 0.063 again. So there's your 569.965. I should have been able to do that in my head. And then looking at our question here, you can see 0.965. So we're two standard deviations away. And then if we go back the other way, we end up with, if you do the 0.839 minus 0.063, you get the 7.7, right? And so that goes here. And then you got to do one more standard deviation away, 0.76, 0.063, and so then you end up with that 0.713 here. And so then you can see 95% of the data would be two standard deviations from 0.713 all the way to 0.965, and that's where you get the 95%. And so again, that's how you would go about approaching that problem there.